With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The given question is a small block of mass small m is kept on an inclined surface of a wedge of mass capital M. The inclined surface of the wedge makes an angle theta with the horizontal. The wedge is kept on a frictionless rigid horizontal floor. You can neglect friction between the block and the wedge also. An external agent applies a horizontal force F on the wedge. Now, the value of force F so that the wedge remains at rest is F1. Which of the following options is incorrect? So now let me explain the figure. So we are having a wedge on which a small block of mass small m is placed. Okay, and the wedge is having an inclination of angle theta. The surface between the block and the wedge given is smooth. Now there is an external agent is applying the horizontal force on F. Okay, like this. Now the value of this force F is given to be F1 to keep the wedge at rest. Okay, this wedge is given is at rest. Now we have to tell which of the following options are incorrect. So these are the given options. Okay, if the F1 is less than mg sin theta, F1 is less than mg cos theta, F1 is not depending on capital M, and it is not possible to keep the wedge at rest. So here we have, see, the value of F to keep the wedge at rest is F1. Okay, so the applying force is F1 here. Now, see, if I talk about the this small mass M, so there will be a normal reaction force acting on this block M, right? And its mass mg will be acting in downward direction, whose component mg cos theta will be acting in this direction. Okay, let me write the components here. So mg cos theta will be acting in this direction. Okay, so if I balance the forces on the small block of mass m in this direction, we will get n equals to mg cos theta. Okay, so let this be question number 1. Now, if I draw the FBD of the wedge, I will get here. See, there is a force F1 acting on the wedge in horizontal direction like this. Okay, next is the mg force of the wedge acting in the downward direction, capital M into G. Next force is the this normal force by the block on the wedge. Okay, so it will be in this direction. So this will be N. And last one is the, let's say, N1 is the normal force acting on the wedge due to ground. So this is the complete FBD of the given wedge. So, and this angle will be theta. And if this angle is theta, this component will be N sine theta. Okay. So now if I balance the forces in the horizontal direction only, so sigma fx must be 0, and similarly sigma fy must be 0. So here I just have to find the value of f1, so I will use this equation only. Okay, and for this equation we will get f1 must be equals to n sine theta. Okay, and we can put the value of n from equation number 1, and we will get mg cos theta sine theta. Right, this is the final expression for f1. Now from the given options A, B, C and D, let's check one by one. In option A we have f1 is less than mg sin theta. Okay, now see, the value of cos theta lies between -1 to 1. Okay, because see, cos theta is less than 1 only, so we can say that f1 will be less than mg sin theta, right? So this statement is true, so the given option A is correct. Now coming to option B, we have f1 is less than mg cos theta. Okay, again see the sin theta, the domain of sin theta, or we can say the range of sin theta is less than 1 always. So we can say f1 will be less than mg cos theta also, right? So the given option B is also true. Third option is f1 is not depending on capital M. So as we can see from the expression, there is no capital M term in the expression, so option C is also correct. In option D we have it is not possible to keep the wedge at rest. Okay, so see here we have find the expression for the force to keep the wedge at rest, so this statement D is false. From the given options or statements, A, B and C statements are true. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.